Let's look at an example of X-ray scattering off of sodium chloride, which is a cubic crystal. If you imagine scattering X-rays with a wavelength of 1/4 of a nanometer off of this lattice and observed a first interference maximum at an angle of 26.3 degrees, could you use this information to deduce what is the lattice spacing, or the distance d between atoms in this particular cubic lattice? According to the Bragg formula, a multiple of the wavelength has to equal 2 times d times sine theta in order for constructive interference to occur, where theta is the angle of incidence and angle of reflection, d is the distance between the lattice planes, and lambda is the wavelength of the X-rays. The smallest angle theta occurs when n equals 1, so if we insert that into the Bragg formula, then d, which is equal to n lambda over 2 sine theta, becomes 1 times 1/4 of a nanometer divided by 2 times sine of 26.3 degrees. In this case, d is 0.282 nanometers. So scattering experiments like this can be used to deduce not only the crystal structure but also the dimensions of the crystal lattice.